We are Coinage. We are a very small team based here in Sydney. What we do is help clients who want to build based on blockchain or cryptocurrency types of solutions and actually ship their code to the world. So there are very few companies like us at the moment. We hope that there will be more. And the whole point of tonight's talk is to be able to get you guys to the place where you can actually build this stuff, because I think everybody should be able to use these tools. I've oriented this, as you might guess, towards JavaScript developers, so we can talk about differences specifically with JavaScript. But we're here doing this talk specifically so that people can walk away tonight knowing how to build stuff on top of Ethereum. So one of the things we've done really poorly as an industry, particularly in blockchain and cryptocurrency development, is avoiding jargon. We have invented reams of the stuff. That's why there's an entire presentation at the beginning of tonight just talking through the jargon. There's way too much of it. It's crazy. It's not actually that hard. So I'm going to simplify stuff. I'm going to talk through each word, give you a one-sentence explanation of what it means so that you can build with it, and then we're going to move on. That's all we're going to do. I'm also only talking about Ethereum. There are other platforms. They work differently. They have different words, whatever. Ethereum is the most widely used platform for building on top of when we talk about blockchain solutions, so that's what we're covering tonight. So it's all about just letting you build things. And by the way, go ahead and Google, hop on your phones if you want to get a little deeper understanding of a word that I just kind of glossed over. There's plenty, and obviously you can come talk to us during the break and we'll happily chat through anything that you find confusing. So now we're just going to start with the definitions. This is going to be a little bit of a different presentation format than you guys are used to. You don't have to wait to ask questions. The reason I'm doing that is because I'm going to rapid fire words at you. So if we get to the point where I'm like going too fast or you didn't get it, just stop me and I will come back and talk about that thing. So I've already said Ethereum tonight. All Ethereum is, it's a blockchain platform you can build things with. Those things aren't just currencies, they're whatever you want. And what we're actually going to demo tonight is not building a cryptocurrency, it's building a blockchain-based application. And you'll see what that does soon. Ethereum was made by this guy. His name is Vitalik. He's Russian. He's way smarter than me. He's also way younger than me. Watch him. He's interesting. He's a visionary in this space. He's one of the few people in the world that I would say can genuinely say they're changing the world and mean it. So mining. You probably have heard about mining. What is mining? Mining is just a way that ensuring transactions are valid. Because in this world, we don't have a central server. We don't have a thing we can talk to that confirms the data and then puts it in a database. We have to have a way for making sure that the data that we're putting in there is valid. That's all mining is. What is gas? Gas is a fee that you pay so that people will mine your stuff. So when they're doing that confirmation, because it's all decentralized, we have to pay for that computation time. We do that with gas. What is a smart contract? A smart contract is a program. That's it. It has variables, it has functions. Anybody in the world can interact with it. There's nothing standing between you and a smart contract. That's what makes it feel a little bit different from a development perspective, because there's no like back end and then we're going to expose these routes. Everybody can just talk to it whenever they want, but that's all a smart contract is. Transaction. A transaction is a request to change data on the Ethereum blockchain for tonight. What is a block? Guys starting to glaze over yet? I hope not. Are we all still here? Okay, cool. A block is an array of transactions. Now, there's more to it technically, but that's all it is. It's just an array of transactions. It is also immutable, and this is the big thing that's different with blockchain versus other technologies that we see in the past. Once there is a block, you can never change it. So what is a blockchain? It's an array of blocks. That's all it is. Still following? Cool. So this is... The array of blocks is, you can add to it, but you can never remove from it. So one of the things that's interesting with blockchain development is these things are growing in size. 300 years from now, not sure how big they'll be. We'll find out. Yeah? The transaction's mutable. Once they're confirmed in a block, they're not. So a block is an array of transactions. Once that gets made into a block and put on the blockchain, that's it. It can't change anymore. So one of the things that's interesting in a decentralized world is there was a guy, I think it was about 3 weeks ago, wanted to move $84,000 of Bitcoin and wanted to pay a $100 fee to do so. and he switched the numbers in the inputs and accidentally paid an $84,000 fee to move $100. When the miners confirmed that block, they sent an email to their pool saying, congratulations, you might notice you got a little extra money this month because we got this giant fee. But who do you complain to? It's decentralized. Computers are controlling it. So one of the things that's really interesting about this when you start getting into it is it feels very cutthroat, because if you do make a single mistake, it can really mess you up. And there's nobody you can complain to. The system works how the system works, and that's how it is. So a lot of people say, I want to be my own banker. And I'm like, do you really? Are you sure? Because people click buttons all the time, and they don't know what they're doing. So anyway, I digress. So this is a blockchain. There is a root block, also known as the first block. Very exciting. We have orphan blocks. So if somebody was to try to create a fork of the chain, if you've ever heard of currencies forking, this is what's happening, is the chain goes along and then it splits at some stage. Now, orphan implies that they never got confirmed. So it's possible for you to try to do that and fail. And then the valid blockchain is our array. So when I say array, I'm a little bit simplifying. It's more like a tree, but again, for tonight, it's an array. That's fine. We got it. Cool. So a hash. I think we know this one already, most of us. It's just a data fingerprint. It's exactly like a Git hash. It just takes the data and hashes it. It's exactly the hash you're used to. A dApp, or a dApp with a line through the D. Very exciting. All it is some sort of application that interacts with a blockchain. Which is a fancy way of saying a website. Cool. What is an address? An address is just a unique identifier where you can store things. Now I say things, not currency. There's a big distinction there, because an address can hold, you can associate data with any address that you want. So it's a unique identifier. It's like an ID in a database. Where do we get that? We get that from your public key. That's all you need to know about your public key for tonight. It's just a thing that you use to drive the address. And the private key that goes with that public key is how you identify yourself to the network. So when you need to do a transaction, you say, I've signed this with my private key. Can't you all see that? Yes, cool, that's me. Do the thing. So that's it. We've also got wallets. Wallet is an array of addresses plus your private key. So the ability to sign transactions, and it holds a bunch of accounts for you. Sometimes one, sometimes many, up to you. Now we're getting into the funky stuff. MetaMask. MetaMask is a browser extension that has a wallet integrated. It can also talk to smart contracts. So that's what we're going to use tonight to build our dApp. That allows us to talk to the Ethereum blockchain from the web browser using a programming language you might have heard of called JavaScript. This is what MetaMask looks like. I'm going to go ahead and just let my video play here. You put in your password. A little fox face watches you. It's very exciting. You're welcome to take that. There's nothing in there. Take my account, whatever. Very exciting. Don't ever tell people your phrase if you actually want to keep your money. Just an idea. So once we've done that, we have an account, and you can see you can send Ether to people, but it's just a wallet. It just holds stuff. And you can say, I want to send transactions. That's all MetaMask is doing. Web3. Web3 is a library that lets us build these dApps. It talks to the blockchain. It signs transactions. It does this in JavaScript. It works in the browser, and it works from Node. So it's just a JavaScript library. That's all it is. So now this is where it gets a little bit weird, because we already co-opted the word node for our own thing. But what an Ethereum node is a server that helps confirm those transactions. So before, when I said miners are confirming transactions, those miners are running nodes that do that. So they make blocks. This is one visualizer of that. So I'm going to see if my internet is still working. We'll find out here. Oh, no, it is going to open.
Is the terminology of mining the same for Ethereum as it was for Bitcoin?
Yeah, similar. There's a little bit more in Ethereum mining, just because it can run smart contracts as well as actually doing the thing. Oh, of course. Maybe I'll just go back in yours. Speed limitations meaning? Scaling limitations? Yeah, so one of the big challenges for blockchain developers right now is the ability to scale up the solution. I don't know if my internet's going to actually work for this one. I'll fix this later. Nah, that's fine. I'll just keep going. Yeah, we have real problems in terms of scaling right now. Reason being is everybody has to reach consensus. This is really tiny, so apologies, but basically what you would see if this was live is all those green rows would sit there for a bit, and then every once in a while you'd see one change, and then the rest will go down the line, and they'll all change as well. So this is all the nodes reaching consensus as to what the next block in the blockchain is. The reason we have scaling problems is because there can only be so much data that you put in that particular block, and there's limitations on how quickly we can mine those, and it's all happening by solving really hard computer problems, which means we can't do them very quickly. I can talk for a while about this, so I'll cut it a little bit short by saying we're working really hard on this problem, and proof of stake is coming, a bunch of other things are coming. Doesn't matter for tonight for building it, but yes, one of the things like the way I explain blockchain to clients is I say it's a 386, it's in the corner, it's plugged into a really slow network, and if you want to put stuff on it, you have to pay. Now, do you still want to use it as a database? Because I don't. It's not a database. It is a very specific technology used for very specific things, and most of your application data probably should still live in a database, unless it needs to be publicly visible, immutable, etc. forever, for all time, and you're willing to pay at least 40 cents to put the data in. So that's the really high-level version of that. I clicked on it again. Didn't want to do that. I want to click down here. So only a couple more. How are we going? Is everybody, we're good? Cool. Okay, Geth. Geth is short for Go Ethereum. Reason why it's Go Ethereum is because it's an Ethereum node that was written in the Go programming language. Very exciting. So this, when we say an Ethereum node, it's running Geth. There are others, but this is the main one that people use. Infura is Geth nodes in the cloud. So somebody's running these for you. So when we use MetaMask to do a transaction, it's actually talking to Infura, which is actually running a Geth node. So they're not that scary terms. There's just a lot of them. So the thing with Infura is, like, if you send them a transaction, it's kind of up to them whether they really put it on the blockchain or not. So you are trusting them a little bit, which is why if you don't want to trust them, run your own node, but up to you. Yep.
Sorry. MetaMask, does that run always on mainnet, or?
There's a drop down.
Okay, cool.
We'll get there.
Cool.
So tonight what we're going to demo is actually on a test network, which lets you guys all get Ether and actually play with it if you want, live as we're going. So it's not going to cost you any money, and you can see it's kind of like a staging network for Ethereum called Rinkeby. We'll get there. More words, fancy words. Truffle. Truffle is a bunch of tools. It's just a Swiss Army knife of tools that help you build Ethereum-based things. Solidity, we talked about already. It's a programming language designed for building smart contracts, which are programs, but a little bit different. Bytecode, still following? So when you take a smart contract, you have to compile it. That compiles down to bytecode, just like Java or any number of other languages that compile down to these bytecodes. And you push that bytecode up to the Ethereum network, and that's your smart contract that people can interact with. ABI, application binary interface. It's like an API, but for your smart contract. So this just says, here's a function. It's called this. It exists at this offset in the bytecode. You can call it like this with these function parameters. It's just telling other programs how to talk to your smart contract. Cool? I know it's so many words, but like legitimately, you'll see how they all plug together, and it's not too scary. But just to make sure it all sinks in right now, let's try some paragraphs. See if we got it. Okay. So I built a dApp with a Solidity-based smart contract. You can access it via Web3 and MetaMask. You can get the ABI from the dApp and do whatever you like. Yeah, got it? Got it? So,
Wait, I blacked out for the ABI.
yeah, so the ABI is like an API, but at a binary level so that you know how to talk to the smart contract. Web3 is a library in JavaScript that lets you talk to the blockchain. MetaMask has Web3 built into it, just to really add more confusion. Cool. All right, how about another one? Can you sign and deploy that bytecode to Infura so I can test with the latest version of MetaMask and Geth? So I want you to take your smart contract, put it on the blockchain, so I can try it out. That's literally all I'm saying. It's a lot of jargon. That's all I'm saying. Infura is kind of an irrelevant inclusion there, but I just wanted to throw it in to make sure we remembered the word. Cool. I think we've got it. There's one more, though.
Well, Bitcoin is a peer-to-peer digital currency. Anonymous and decentralized. It's like being able to teleport money to anyone across the world. No, I think it's nicer than being teleport. So they can compute each and every Bitcoin on a public ledger called the blockchain. If you want to send someone a Bitcoin, you publicly announce that your account can send your Bitcoin to the recipient. The letters of public record and one of those Bitcoins are associated with each account. If you let anyone can send money to his name. The whole thing, you have bank law and then you go lock up. Make sure bandits didn't ride off with it. Bitcoin not only exists as protected on the blockchain, there's nothing to keep banks in the dark. All the matters are private key. Your Christian Catholic account there, and your access to account to send money from.
Vince Florento, Keymaster of Closer.
As long as you're tasking, no one can see other Bitcoins if you're exempt from anyone. That's why Bitcoin is protected at any play. Common stack, rent stuff, even the Winklevoss coin. Want to have Bitcoin for yourself? Don't have fun. Saying that, it's like a digital currency for which you have Bitcoin. And somewhere, say US dollars, at least for now.
So just in case it wasn't clear, he was intentionally mumbling, but that's how this all sounded to me before I started working in it. So now you can sound like one of us. We can say all these crazy words to each other and nobody can understand what we're talking about. No, the whole point is to try to demystify this stuff tonight. So if we say words, like as we go through the actual doing of the things, if we say things and you forgot what they meant, it's not a dumb question. Raise your hand. We'll re-answer. It's fine. There's a lot of words. They're all very simple words. So any questions?
How does fees work with apps as opposed to currency?
The user that wants to make the change in the data pays the fee. Yeah, you pay, so Ethereum, the currency for the Ethereum network is called Ether. You pay those fees in Ether, and you'll actually see that when we start interacting with our dApp at the end of the night, you'll see it saying, and we're going to charge you this much Ether as a transaction fee for doing this. So reading data from the blockchain is always free, but writing it is where you have to pay. So if your data is constantly written and hardly ever read, bad fit for blockchain. If it's the other, then it's fine.
So if you got a whole bunch of nodes trying to work out what the next block is,
Yep.
to put on the chain, are they all working on their own block at the same time? And then how do they reach consensus on which is going to be the next one on the chain?
So so basically the question is how does a block get really confirmed? What happens is all the transactions pile into this array until it fills up, and then the nodes take that and they all try to solve this really hard math problem. When one person manages to solve it, then they prove that solution to the rest of the network, and then everybody goes, cool, you've done that. And those are legit records.
Is there more than, there must be more than one node working on that problem at the same time?
Yeah, there's hundreds, yeah.
So like, you know how before you had the, sorry, can I jump in? No?
No, you can't.
Well, there you go. Okay, so
You can come up here.
So the diagram we had before with the main chain and side chain,
Anthony,
what happens?
try again.
Hello. Oh, sweet. Okay, so hi, I'm Anthony. The main net, the main blockchain, this diagram here, so this side chain's here. So what happens? Because we're in a decentralized space, someone can solve the same problem twice. Yeah? So what happens in that case is we create a side chain. So at some point, the network will come to consensus over which chain is the main chain, and the transactions kind of get moved onto the main chain.
Yeah.
Yeah?
Does that
answer the question?
I guess it was a two-part question. How did it reach consensus on that?
So that's where you start getting into solving really hard math problems. They're doing it by basically finding a nonce that will make that reach the next highest hash value. So it's a lot of words. Basically, my recommendation is read up on that. Because like for tonight, all we need to do is say they're solving a hard math problem, they're going to reach consensus. But yeah, or talk with me in the break. Like happy to talk through it. Cool. Any other questions? Go. Let me see if I can go. I can't go lightning speed through this now because I put in all those animations. So I think that's it. Yeah. So I think we're ready to actually build a smart contract. Do we feel ready? No? We should be. We're ready. We know everything. We're good. Let's do this. Cool.